So if there are periods of inactivity or bubbles of inactivity, sort will be entered transparently. This is done when superspeed sends idle symbols. The concept of idle symbols in USB 3 is there. When that sends, instead you can enter stall in a transparent fashion. Now superspeed also defines 3 low power states, U1, U2 and U3. U1, U2 are meant to be hardware autonomous low power states. So anytime an inactivity is seen on the link, there are inactivity timers that are configured, and when that inactivity timer expires, you enter either U1 or U2. U3 is the deepest low power state and is typically directed by software. So when software knows that this link is going to be inactive, it will transition the link to U3. So in SSIC, each one of those states are mapped to M5 states. U1 maps to stall, and this is done directed by the link layer, because the link layer knows that there was inactivity for a certain period of time and it enters stall. And though you can enter stall transparently in U0, in U1 there are additional power savings. So even the M5 may be installed, but now maybe your controller can be clock gated because it knows that it's in U1. U2 maps to hibernate. So this is again another hardware managed autonomous state, transparent to software. So when the U2 inactivity timer expires, you go to hibernate, and this is directed by the link layer again. And when software suspends the port with USB terminology, the link is moved to hibernate with U3. And both U2 and U3 map to hibernate, but at U3, since software has directed it, there are additional power savings at a system level. So for example, in U2, you may only be clock gating the controller or power gating the controller, whereas in U3, you can enter the entire system in a suspend or a sleep state. The U2 defines exit latency by which you have to exit the link. So that is defined in the specification. Whereas U3 is typically done with a handshake. So when one remote link partner wants to exit U3, it indicates to the other end to exit U3, but only when the handshake completes will U3 really be exited. So that was the link layer summarized in 5 minutes. Next up is, in the layer above the physical end link, is the protocol and the device framework. Now in USB, there are mechanisms for detecting attach and detach of a cable to a port. And this is typically done using the concept of V-bus, which is the power in the cable, or the concept of far-end terminations on the link. Now since in SSIC we're not using the standard SuperSpeed 5, we don't have a V-bus, we don't have any concept of far-end terminations, SSIC defines new mechanisms for connect and disconnect. And the whole idea is to support what are valid use cases for connect and disconnect. Even though this is a device inside the board, nobody's really picking it up and attaching and detaching it. There are valid use cases, and this may include power management of the link if you want to completely power off, for example, a modem, or if the device wants to re-enumerate with a different profile. Maybe it connected with a certain profile and has a need to disconnect and reconnect with a different profile. So in order to do this, and to do this in a way that is transparent to software. So software is under the impression that the device is being physically attached and detached by a user. So SSIC defines these mechanisms for connect and disconnect, and they are related to software as if they were valid attach and detach events. So USB stands for an upstream port, and DSP stands for downstream port. So in the traditional sense, downstream port is a host, and an upstream port is a peripheral. So the upstream port, a peripheral, can signal a disconnect by actually doing a line reset. So anytime there is a line reset seen by a host, it will detect it as a disconnect. And the downstream port disconnects by doing a specific RRAP command. So that is done by issuing a reset. The peripheral thinks it's getting a reset, it comes back up, and then it actually gets an RRAP command saying, oh, I've disconnected. So as mentioned, this allows transparent, these mechanisms to be implemented in a way that is transparent to software. I wasn't planning to walk over this, but the spec also includes an appendix. There were a lot of corner cases in the specification when we walked through the various M5 transitions to hibernate and to stall and line reset and such. So the appendix includes a waveform that exactly walks through the line transitions and what happens on an RMI interface, for example, when you enter U2 and U3. So this is just FYI, and more details are in the specification regarding these timing diagrams. So the SSIC work group took a goal to do a proof of concept or a prototype prior to doing the 1.0 ratification of the specification. And the whole idea is that nobody really reads the spec until they actually start designing it. It's true in a certain sense. And also to show that the value proposition, which was software reuse, was not broken. So for example, to show that none of the Win8 or Win7 or Linux host or device drivers need to be modified in order to work on SSIC. So the prototype targets were to get hosts and device from a couple of different vendors and use unmodified host and device drivers on both sides. And this was done using FPGA cards. So on the host side, we have the host SSIC IP, and on the device side, you have the device SSIC IP. Now, since SSIC is treating MIPI as a black box, it should assume that the MIPI is operational. However, there are a lot of transitions, as we talked about, for entering and exiting Hibernate, which may have corner cases. So the MIPI digital was integrated into the prototype. So all the M5 state machines, all those implementations are there in the prototype. The only thing not there is the AFE. So there is no AFE, and the actual interop at this level is a AFE-less version of M5. For example, it's a parallel version of M5 with sideband line state information such as diffp, diffm. So the full digital portion of the M5 was integrated on both sides. So the following functionality was demonstrated, which includes reset, RRAP, entering high-speed burst, transitioning to U0, enumerating a simple mass storage device and doing actual file transfer back and forth, and entering low power states. So there is a super speed CD test, which is the compatibility validation test suite. It's an elaborate set of tests that are used to validate standard super speed. That was also run, and the whole CD test was passing. Now, unlike USB 3, which has to include backwards compatibility with USB 2 and USB 1.1, SSIC is an in-box application, so it only supports super speed protocol. So it doesn't support a fallback mode into USB 2 high-speed modes or low-speed, full-speed modes. So the only test that was failing was the test that verifies that it goes to the fallback USB 2 high-speed mode. So I think the focus of the SSIC workgroup going forward is in compliance and interop, and there are various levels at which compliance and interop elements are provided. So there's device framework and interop testing at the software level, there's protocol testing, there's link layer testing, and there's electrical testing. So the assumption is the M5 is the physical layer is covered by M5 tests. The focus is on link layer testing because that's where most of the modifications are. Protocol and above, all the existing super speed infrastructure is reused as is for SSIC. So for link testing, here is a list, a laundry list of some of the things that are tested. Link robustness, the various timers in the link layer we talked about, such as U1, U2, and entry timers. The flow control sequences and the CRC check sequences, and reset as well as disconnect and reconnect. So today the focus is on single lane testing for the compliance vehicles at this point, with multi-lanes planned for a future time. So the plan is to come out with a link test spec in the middle of this year, or more likely in Q3. There is a link verification system planned, and that will be more or less based on the SuperSpeed LVS. And there will be an updated list of framework and interrupt tests that we talked about in the higher layer, and that's mainly based on the SuperSpeed framework and interrupt tests, most likely taking out the tests that are not applicable to SSIC. So this is just showing the technology timeline. So about April last year is when the collaboration was signed between MIPI and USB 3 promoters group to do SSIC, and the work group was kicked off. The 1.0 has been released or will be released anytime now in this week or the next week. And the focus now is on compliance, on the compliance test spec. Now going forward beyond 1.0, there's various candidates for future work being defined at this point, such as asymmetric configurations and different form factors, as well as to do actual functional data transfer in low-speed gear mode. There is no actual timeline defined for any of these at this point. Okay, so SSIC is here, 1.0 is released. If it should be included in the USB 3.0 zip file. I checked this morning, it's not there yet. It should show up anytime this week or early next week. So if you go to the usb.org, you should be able to download a USB 3 zip file that includes all the USB 3 core spec, ECNs, as well as the SSIC supplement, as well as some other supplements. Oh, and of course, from a structure perspective, the SSIC spec, didn't talk about this, but it's a supplement to the core spec. So it's not a standalone document. It is meant to go along with the core spec. So as we continue to use SuperSpeed for out-of-the-box ports, we can now use SSIC for inbox connections as well. And that's about it from a summary perspective. Any questions?
So this spec or adaptation spec is completely, as you say, defined by the USB forum. The MIPI was not involved into
the structure of USB is that there is a USB 3 promoters group that defines all USB 3 related specs. And in that promoters group that defined the SSIC, there was an SSIC work group. There were a lot of members from MIPI. Actually, every member that was there in SSIC was also a MIPI member. Because the SSIC spec requires, in order to implement this and get the same licensing conditions that you would get if you were a MIPI member, you have to be a MIPI member to use the M5. So in a sense, MIPI consortium wasn't involved, but there's basically the same members on both sides in the promoters group.